In this video, we will continue with revision exercise 3 of graphs and functions and coordinate geometry. You will find this on page 136 in the Namibian AS-Level Mathematics textbook y equals mx plus c to success. So in this video, we are going to do number 3 and number 4. You can stop the video and you can first try it on your own, and as soon as you are done, you can continue the video. Let's start. Number 3. The 2 points A and B have coordinates -1, 1 and 3 and 4 respectively, meaning that A is going to be -1 and 1 and B is going to be 3 and 4. The lines BC is perpendicular to AB. Now, it's not always, but sometimes if you feel, and you may never use a graph to really help you in coordinate geometry, you can, no, let's rather say it, you can use a graph to help you, but not to prove something unless they tell you. So in this case, okay, I just want to make it say what? You can have a picture just to help you a little bit understand it. So if you look at this one, say in this case, it's -1 and 1. Okay, there is A. And B is 3, so 1, 2, 3 and 4. Okay, it doesn't matter. It's more or less that. Okay. Even do it with a pen. It's a straight line. Okay, so that's B. But then I go on. The line BC is perpendicular to AB, but that always no, it's just perpendicular. It's not a perpendicular bisector. Take note to AB because it's starting also at B. Do you see? And intersects at C. So meaning yes, that line starts at B. And I have to take a ruler now. And it's making that 90, if I can now with my eye stretch it a little bit. And this one is also a little bit longer then. Okay, so, and then they say, and intersect the x-axis at C. So that is going to, where it intersects, it's going to be C. Okay, and there is going to be the 90. It's not perpendicular bisector, it's just perpendicular. So make sure that you are not misreading or read too much in the question. Now, let's start with number A. Find the equation of BC. Okay, so let's now just go and find the equation of BC. Now, the first thing that we are going to do is we're first going to find this gradient because we have the 2 points. So we're going to find, okay, I'm just even going to leave out first that. I'm going to find the gradient of AB because that's going to be y2 minus y1 over x2 minus x1. Remember, this is x1, y1, x2, y2. So that is going to be 4 minus 1 over x2, 3 minus -1. And that is going to be 3 over 4. Okay, that's my gradient. That's my gradient of this yellow one. So m is 3/4. Now I can go to my, okay, so therefore perpendicular and that's m of BC, and that's perpendicular, is then -4 over 3. So this one will be -4 over 3, the value of m. Okay. So now I have the point B. I have the point B. So I can find, and this is what they say, find the equation of BC. Okay. So if I must find the equation of BC, and I have the point B, that's 3 and 4, I'm just going to use my, say, y minus y1 equals m x minus x1. So in the place of this is just y1, oh, let's just get my pen correct. So this is x, this is y. So y minus 4 equals m and x minus 3. And I just simplify. Oh, I forgot to fill in m. I have m. There is m. So it's negative 4 over 3. And I simplify. So y minus 4 is going to be, okay, let's just multiply this side with the 3 already. Then it's just the negative 4 on that side. Okay, then we move up. So we get 3y minus 12 equals negative 4x plus 12. Okay, so 3y is equal to negative 4x. That's the 12 plus the 12. So 3y is negative 4x plus 24. Okay. So basically, if I'm now going to simplify or to get that equation, let's just find that. So I'm not done. I divide 3, I divide 3, I divide 3. So therefore, and that's the equation of BC, is y is equal to negative 4 over 3x plus 8. That's my equation of BC. So find the equation of BC and the x coordinate. Very important, not the coordinate, just the x. So if I want to see where it cuts the x-axis or the x-intercept, I make y 0. So I'm going to say 0 is equal to negative 4 over 3x plus 8. Okay. And if I simplify this, I can, it doesn't matter. Negative 8 equals negative 4 over 3. There's the x, there's the 1. If I multiply, it's negative 4x equals negative 24. If I divide negative 4, divide negative 4, I get that my value of x is 6. Okay, so the x coordinate, so x coordinate of C is 6. Okay, now I go further. Find the x coordinate of C. Find the distance AC, giving your answer correct to 3 decimal places. So okay, let's just go back to my graph. And I think I'm going to even do it here so that you can see everything. Okay, they want now the distance that of AC, that. So I know the point C, don't forget that point C is 6, 0. And I know the point A, there is A, it's negative 1, 1. Okay, so if I do that number B now, we can even do it in red. I'm just going to say, okay, this is my point A, it's negative 1 and 1. And my point C is going to be 6 and 0. And that's very easy. This is x1, y1, x2, y2. What is distance formula? Okay, well, distance, let's just write it better. Distance AC, that is Pythagoras theorem. So it's the difference in x plus the okay, I'm going to write it first. The difference in y squared plus the difference in x squared. And if I substitute that, it's going to be 0. No, let's just go 0 minus 1 squared plus 6 minus negative 1 squared. And that is going to be negative 1 squared. This is going to be 6 plus 1, so it's going to be 7 squared. That's going to be 1 plus 49, which is the square root of 50. But now let's just go and read the question. Let's just read the question. Find the distance AC. This is very correct to 3 decimal places. Always underline that. So if I press this on the calculator, I'm going to get 7.071 units. Always, as soon as you are done, read the questions to make sure you are answering everything. And that was the first one. Number 3 in this video. but actually number 3. Let's do the last one. Okay. Let's just move it down. Let's just make space. I just want to clean also this a little bit. Okay. Sometimes, as I said, if you just have a rough sketch, it's just helping you a little bit in this. If there's not a sketch, sometimes they give you a sketch like this one, and then it's actually nice, and you can even work on the sketch just to help you to get all the information. Okay, let's start with number 4. The diagram shows a kite OABC in which AC is the line of symmetry, meaning that the kite will come actually like that. Do you see? Okay. Then they give you the coordinates, and maybe it's good to write it in. Of A, it's in. C, where is C? And C are 8 and 0. Oh, they gave you all. And O is the origin. Okay. And then they ask you to start with the question. So, let's start with the first one. Find the equations of AC. Where is AC? That's fine. So let's just start with that one. I always like to first write down the points. So this is A, 0, 4, and this is C, 8, 0. Okay. This is x1, y1, x2, y2. Okay. And now I'm first going to find my gradient. So the gradient of AC, and that's going to be the y2. So in this case, I'm just going to write it. And x2, okay, 0 minus 4. Okay, so 0 minus 4, and then 8 minus 0. And that is going to give me negative a half. Okay. And then I'm just going to find the equation. I can take any point. I can take this point. And I can just say y minus, I'm taking this point. So y minus 4 equals negative a half. And then x minus 0. Okay. And then I have y is equal to negative a half x plus 4. And then I just write equation of AC. Okay. And then I'm going to find the equation of OB. Now, OB, I can do it in any way. I can basically say, I know that this is perpendicular, or, yes, I have to work with that because I don't have the point B. So I must know that, okay, I'm first going to draw a normal kite to you. Because sometimes if it's a little bit on its side, you maybe struggle to see. So a normal kite, I just want to take rather another color. The mine is now not so good, but they intersect with how many degrees there? 90. So meaning that that line there and that line there, it's going to intersect with how many degrees? 90. So if you have that this gradient was negative a half, again my pen, then you know that this gradient is going to be the reciprocal, it's 2, and it's going through the 0, it's going through 0, 0. So if you have now the gradient, okay, let's say the gradient, perpendicular, or let's rather say perpendicular gradient of OB, and that's 2. And you know that's the point 0, 0. Okay, so if you really, and I think you can already see it's y equals 2x, but let me just show you. It's going through the point, the origin, 0, 0. So if you really want, so that's x, y, 1, 1. So then you can say y minus 0 equals to x minus 0. Okay, I'm doing just to explain it better. So y is equal to 2x. And that's the equation of OB. Okay. So I have OB and I have AC. That's the 2. Now, They say, find by calculations the coordinates of B. Okay. Now, I'm first, because I have this two, remember, okay, this is now blue. Let's rather make it just blue. I have this one, right, do you see? And I have AC. What my AC, unfortunately, it's now, but let's make it yellow. I could have made it red, doesn't matter. But do you see that this line here will intersect the blue line? The yellow line will intersect the blue line, basically. That's what you can say. So but first, I want to find the point of intersection. There where it cuts. Okay. So remember, it intersects. That's very important. But I first want that point of intersection. Now, how do I find that? I have the two equations. I have this equation and I have this. It's where the blue and the yellow intersect. So I can go and say, point of intersection of of AC and OB. Okay, and that is going to be, let's just do that also. So it's going to be, and let's just put the y, it's putting this one equal to this one. So I have 2x equals negative half x plus 4. Okay, then I go up. So this is 4x equals negative x plus, remember, I put it over 1, multiply 2, more, so I'm getting 8. Okay, so if I simplify, I take this one over, so 4x plus x, that's 5x equals 8. I think what makes this one difficult is that we're working with fractions. It would have been so much easier, just have to clean this, if there was not fractions. Okay, so this is fractions. So that value of x is 1 and 3 over 5. So how will I find the value of y? Just substitute. So if I have, okay, if I have that y equals 2x, then it's 2 multiply that 8 over 5. And that's going to be 16 over 5. And that is going to, let's simplify, 3 and 1 over 5. So what I'm showing you here is that point. Now, if that coordinate, let's just call it M. Okay, M. If that is 1 and 3 over 5 and 3 and 1 over 5, what does it mean? It means here, it's 1 and 3 over 5. And here it is 3 and 1 over 5. Okay, because, why do I need that? I want to find the coordinate of B. Now remember what I said, this yellow. I said this little blue, this blue part is the same as that blue part and it starts with 0. So that means if I want to see this x value here, it's basically just double. So it's 3 over 5 times 2. And if I want to see that y value there, it's just this one's double because it's working from 0, 0. So basically, I can just say, so therefore, I can say point B, it will be double 1 and 3 over 5. And double 3 and 1 over 5. Please don't write it. It's just your in-between step. Go and simplify it now. Now, if you go double 3 and, so you can basically just press it on your calculator. 1 ABC, 3 ABC, 5 times 2. And that's going to be 3 and 1 over 5. And if you do the same with that one, and you multiply it with 2, you're going to get 6 and 2 over 5. So you can basically say, therefore, point B is that. Okay, and that's how you do it. You can also use vectors, but because vectors, you can go look in the teacher's guide. Your ordinary vectors will also be enough to help you. So it's just showing you that this movement in this and this movement and this is the same. So that's also 1 and 3/5. That's also 3 and 1/5. So if you are taking it from the origin, it's just going to be double that point in. And that's how you do it.